So we can move straightforward to Python. How to do that? Go back to the Google Doc, and here are links to all our scripts. All of these scripts are designed in a way that you have to just open them in your browser. So let's start with this CTA 1 right here. Oh no, this one. Great. So all of you should be able to do this right now using your personal or institutional Google account. So what is this? This is a file. This is a file open in the browser, and it is a file in the format IPyNB, what is a file format called Jupyter Notebook. Jupyter Notebook file is a standardized format for files containing Python code, not only Python, but very often commonly Python code. And it's not only code, it's code and documentation at the same time. So what do you see here on the most part of the screen is just the documentation of the code, not the Python code itself. We see, but the code is starting below, and everything is within cells. Here is very short introduction in the first paragraph that's informing you about this, that this is a Jupyter Notebook file, and this file is now opened via the Google Collaboratory environment. It's not necessary to use this Google Collaboratory platform to use Jupyter Notebooks. Jupyter Notebooks can be used also within things like if you have a local installation of Python using Anaconda, you will have the opportunity to open any Jupyter Notebook format file there as well. But this is practical because you do not need to have a local installation of Python, as we will see below. This file format is very suitable for what is called literate programming. That means that you write your code accompanied with extensive documentation in natural language. That means that you develop some analysis, for instance, and at the same time you write some interpretation, what you are doing within it, not just of how the code itself works, but also with some reasoning of, okay, that's interesting, perhaps we can try this, and then you make it within the code. And this form of literate programming is especially popular in the community of scientific computing or academic computing, because it's very useful for once you prepare a code to publish it in alongside a publication, alongside an article. It's very good to publish the code in this format because it's quite readable for the audience. It's better than once you would just deliver a set of files containing functions for your analysis. With this type of code, everyone can easily or should be easily able to rerun your analysis, just reading from the top to below your code. If you are a R user, you might know R Markdown files. That's the analogy to that. So once you open the notebook, you establish a connection with a Google server, and once you write a Python code here in this notebook file, you do not interpret it on your own machine, at least by default. You interpret it actually on the Google server somewhere. So that means that you do not need so much internal memory of your own machine. So as I already mentioned, the notebook consists of cells. The cells are of two types. The first type of cells are code cells. These are the cells which we will see below, containing Python script, which can be actually interpreted by Python. Next to it, there are these text cells, and actually right now we are within a text cell. These text cells are just for the purposes of documentation. The text cells are using Markdown markup language, so you can easily make some basic formatting of the document. The point is that actually the code cells might be executed. So what is within a code cell has to be properly formatted in Python syntax, as we will see below. And the thing is that you have to execute the code within them, as we will see. While in the case of text cells, you can write everything you want. Like here, we have an extensive text within the Jupyter notebook, which is not executable. And the idea is that once you run a code within one cell, you can, for instance, you define a variable in one cell, and in the following cell, you can rely on that definition and start and build on it further. So normally, you develop the script just cell by cell from beginning of the document to the end. And once you return back to a notebook and you want to rerun it, you have to go to the beginning and start from the beginning to interpret cell by cell, to execute cell by cell. So in what follows, we will experiment a little bit with this environment, and we will use this environment for the whole webinar. So here we introduce the cell logic by introducing two variables originally in one cell, and in the next cell we will use this for some calculation on using these two variables. So you can just skip everything I was talking about so far and go straightly to this section called Introducing the Cell Logic. The fifth step is just to click in by your mouse into the cell. And now, once you click into it by your mouse, you should be able to see this play button on the left side. At this point, you can edit the content of the cell. For instance, you can change the number here, like to put it something like that. And below, I can put another number like this. And so what the syntax here says, on this line, I introduce a variable called first num variable, and I assign a value to this variable, and this value is this number on the right side of it. On the other line, on the other line, there is this, I define another variable of the same type, and again, I assign it a value, and the value is the number 317 in my case here. The first four rows here, are just comments. Everything what is on a line behind this hash sign is skipped by the Python interpreter because it is understood that it is just a comment, which the comment is just for the purposes of documentation or explaining the code. The comment can be also located just behind code, like here. So the Python knows that everything what starts here from here on should ignore. Python is interested only in this case of this line. So once I execute this cell, Python will skip all these 4 comment lines and go to this and understand, okay, here is equation mark. So that means that it's some definition, and this is a definition of a variable, and this is probably a numerical variable because here is a number, and the same in the second case. As I explained here, in Python, actually, you do not need explicitly say what variable types you are using. Python derives this information from the value of the variable itself. One Python see that here is a number, pure number, it knows that actually, okay, it's an integer, and I will work with this variable as a numerical variable. Once I put here a quotation marks, Python knows that now it's not anymore a numerical variable, it's a string variable, it's containing textual data. But let's run this, let's execute this code. You should be able either to see here this play button and click on it. Actually, it takes some time because at this point, the environment recognizes, okay, I should really establish a connection with the server, like here on this side, and it executes the content. So now I execute the cell, and by execution of the cell, I assign this value, this numerical value, to the variable of this name. And since that moment on, I can use this variable in everything what follows until I assign a new value to this same variable. So you can either run it, numerous times. Now it is much faster, and you can use a shortcut, which is Shift Enter. For whenever you are within a code cell and you want to run it, you can use the shortcut Shift Enter to run it. And once you executed this particular cell, you can move to the next one. In this next one, we introduced a third variable, which is called here sum variable. And what I assign to this variable, I make a plus. I use the first variable and plus the second non-variable. So I make a simple calculation, just summing up these 2 numbers which are contained within these 2 variables. So I make a 217 plus 317 in this case, and assign this result to this third variable. So I will enter, Shift Enter here, and now I have a content within this sum variable, which is the summation of these 2. I have a third cell here, and the third cell is for printing the content of the variable. Here you see 37, that's from my previous running of the notebook. You can see the outputs from the previous running of the notebook, and it every time. So, but you will reset this outputs once you run the cells again in your current runtime. So once I run this third cell, I obtain this summation of 217,317. Okay, this is a simple calculation, and this is the whole you need to know to work properly with Python notebook. You just have to run the notebook cell by cell, and through the process you just assign some values to some variables and apply some functions on these variables and produce some results you can print out at some point. So I can modify the numbers here, return back here. I will put other numbers like and rerun the first code cell. Then I move to another one, make the summation, and finally I run the third one, producing the output. Okay, that's useful. That's a way how you can use Python and Google Colaboratory as your calculator. The advantage of this environment is actually that you don't have to have a local installation of Python. So I use Google Colaboratory also for managing our family budget from my iPad. So you can for simple calculations like this. So I think it's quite useful for any ordinary tasks. But of course, we are interested especially in textual data. But very often, our task with textual data is just to transform them into some form of numerical data. So it's important to realize what's behind in terms of numbers. So that's what we did. We played a little bit with the 3 cells above. We rerun it using different numbers. But of course, Python is not just for numbers. It has also an endless potential for working with textual data, since a variable can contain not only a number, it can contain a word, it can contain a sentence, it can contain a whole document, or it can contain even a whole corpus. You can assign a whole corpus as a content to one variable and then apply some functions on this variable. All depends on the task at hand, as we will see below. So now let's move to the second section in this code, text as a variable. So now we will work with other type of variables. These are with textual variables. Python recognizes that something is a textual variable just because of the fact that there are quotation marks. Quotation marks indicate, okay, that's not an ordinary number. That's probably something else. That's probably a string. I will have to work with it as a string. We can put some content from here as our string, or you can copy paste something from a web. Later on, we will use something more complex for that task. So what I did here, I just copy paste text from above and put it within quotation marks here as a value of the text variable. Again, I have to execute it by running Shift Enter. Right? You can put it here anything on your own. Just use the quotation mark, and inside the quotation mark, either insert or write anything you want. Good. I will return back to the few sentences I had here because it was a little bit longer, so it might be more useful below. Oh no. Yes. So again, I will assign it to it, and it's sometimes useful to realize, okay, I have here this variable. I do not remember where I define this variable within the code. So I am interested of what type the variable is. In Python, you have this simple function called type. It is a function. It's not a variable. It is something what is applied on the value here on its as its parameter. So once I run this, it will output here string str. That means that this variable is of the type string. Once I run here, replace, like, take this and put it here. This is the sum variable we were working with above. Python tells me that it's actually an integer. But so once we speak about computational text analysis or quantitative text analysis, the first crucial thing we might be interested in is the number of words a string has. To do this, we can run these commands, and I will explain what's actually here. Perhaps we can do something a little bit different before, something more easy, or not easy, more straightforward. It is so what is very useful. Please, under this variable, where is under this cell type text variable, please insert a new code cell. To insert the code cell, there is a shortcut, but you can also use this on the left top side. You can use this button plus code. Insert code cell below. In this way, you produced a new code cell, and you can write some comment in it. And the command can be, we will apply one particular function here, which is called len for length. This function is in the core Python, and this function calculates the number of elements within a variable or any data structure. So you have this variable, text variable, we define it here above, and now you are interested how many elements are within it. And this function informs you that actually there is 340, in my case, there is 344 characters. You will have a different number here because you have here probably something slightly different, some different text variable content. But in this form, this function does not recognize that this actually is a string containing spaces, and therefore it consists of words. It does not calculate words, it just calculate characters. But it's very easy to modify this command in a way that it will actually return not the number of characters, but the number of words. To achieve this, you have to modify the string into another variable type, or we should rather call it data structure. And this is the data structure which is very common in Python, and it's called list. I will show what I mean. Here I have this command text variable split. I will copy paste it here above into the new code cell I produced, or you can produce any amount of code cells you want on your own. And I will I will now execute this code here. Voila. So what I did here, I use this method, or it's something like a function, but it has slightly different syntax. I use this command here, split, to apply it on this text variable in a way that I use that once there is a space between two characters, it splits the string into two different elements. So in the text variable here, the text variable in my case has this content, text variable content. It might consist of sentences. And here, once I apply this split function, I basically, so to say, tokenize this text variable, this string, into a new data structure. And this new data structure, a different data structure, is a list of elements. And these elements are basically the words within the text. And sometimes, as we will see below, it's even more important to work with text as a list of words than with a text as a ongoing, as a continuous string of words. So it's very common operation, a very common function you do with a string is that you just split it into a list of words. Because once you have it in a list format, you can do many more things with it. You can manipulate each word separately and apply some functions on it accordingly. You will see it below. So here, once I just run it in this narrow form, in this core form, it print out straightforward the output below the cell. That's not necessary. I can use this, and here I actually use the same command, text variable split. So I split it into words. I now have this here. I now have this list of words. I do not assign it to a specific variable. And on this, I apply the len function we have seen above for calculating the number of characters. But here, I apply it on the list of words. So it produces different results. Is it understandable? I will produce new code cells here and make it a little bit slower. So I produce a new variable called a list of words. List of words takes this variable, emerged in this way. It takes this variable, text variable, as one string, continuous string, and makes a list from it by applying the split function. And then in the next step, I use this. I use this list of words and put it as an argument into the len function. And this is the output. And here I do the same. I just skip the middle step. I just skip this middle step of developing an independent new variable called list of words, and put it in a nested structure here into one-liner command. So this is something what is very crucial, that in many cases you actually use one line, and in one line of code you do more operations, you apply more functions on the same structure in a nested way. And yes, another crucial function next to this len function is the count method. We have this list of words here, and let's say we are interested in the number of occurrences of some particular word here, like with. Okay, that's only once there. So very simple thing you very often need is just to know the number of occurrences of certain word within a text. The basic tool how to retrieve this information is just to use this count method. You have this text variable and on it you apply this count function, and here you define what you want to count. So here we have this 4. Again, it's just once here. But once I do this, I modify the text variable in such a way that I put here several occurrences of the word text, and rerun the cell again, and then go straightly here and run count text. I immediately see that now I have 5 occurrences of the word text within the text variable. So in my view, most of things in quantitative text analysis or computational text analysis of or text mining are just some extension of these basic things. You just calculate the number of words in some way or another, and you just compare it with the total number of words within a document or something like that to obtain some more interesting information, and then you compare this between several documents at the same time, or you weight it by some other measurements. So it's crucial to know this logic. And we see that these functions are part of the core Python. So you don't have to install or import any additional Python packages, as we will see below, what is very common thing. So once you want to use Python, I would recommend to play a little bit more with this. You have this notebook for on your own, so you can return to this anytime. Because you would be very easily lost, and it would be not make so much sense to you. So I decided that it would be practical to go through this very basic introduction to Python. One important thing about Python is that in its basic form, as it is on the Google Collaboratory environment, or as you will get it once you make a basic local installation of Python, is this actually not so much extensive and includes only very limited amount of functions. But there is a standard way how to overcome this limitation, and it is by importing packages developed by the community of users. And this is actually something what gives you almost endless possibilities for applications of Python, because anytime you just have an idea, okay, there is this problem I would like to solve with Python, the first thing is you will just look for a package which is already developed by someone else for working with this problem, dealing with this problem. For instance, once I would like just to do some analysis of the current pandemic, the first step would be just to find a Python package which will enable me to pipeline some data on it into my Python environment, and I would have not to develop the functions on my own, because I would probably find some solutions already available for Python somewhere on the web, somewhere on GitHub. The packages in general, once you develop your own package for Python, you develop some sort of functions you would like to reuse in the future, or you would like to find someone else who would use the functions. You can publish the functions as a part of a package. You can develop your own package and publish it on this Python package index called on the platform called PyPy. Once a package is on this platform, it is very easy to get it to any Python environment you have, either your local one or into this Google Collaboratory. In some cases, you have to install it in the case it's not supported by Google Collaboratory natively, or you can just import it in cases where when it is already supported by Google Collaboratory. For importing a package, you just use this syntax. If you want to import the whole package, you just run import and the name of the package with space. In the case you want to import just a part of the package or some function from it, you can modify this from the package, import some set of functions. This command just what it does, it just go to a file structure containing the package, and in this file structure it identifies the file of this name containing Python code and import it into your Python environment. And at this moment, actually, all the functions which are parts of this Python file are now in your Python environment, and you can use it for your subsequent operations. So now we will turn to a simple motivation exercise. We will work with some Latin texts and do some very simple quantitative text analysis on them. For that, we already need some packages we cannot use the core Python itself because it does not support some of the features we will need. So we need to import some packages, and the packages are in this cell on important packages. So please turn to the notebook, return to the notebook, and in this notebook go to this simple motivation exercise and importing packages, and execute this cell either by running Shift Enter. In the case there arises a problem with some package, if you have an error message, what might easily happen, that means that actually you don't have the package installed in your own Google Colab environment. For instance, when I run this is this might happen quite easily. It returns me a error message that the module or the package is not found, module not found error, no module named as DDK. If you see something like this here, for instance, no module named NLTK or something like that, to overcome this, you have to first install the package. To install the package here within the Google Collaboratory environment, you just run this before you want to import the package. But I hope that this will not happen in your case, that all the packages imported here you already have in your computing environment. Good, thanks. So I will let it here. It might be useful at some point. You're already in this notebook. So now how to get to some actual textual data. One option is just to copy paste it into a variable and to assign it to a variable manually. That is something what we did above. Once I just defined this text variable and then use the quotation marks, and inside the quotation marks I inserted the text. But it's probably not so robust solution, and it will definitely not be sufficient once you want to work with a whole corpus or something like that. Another option is that you already have your textual data on your own machine, and you want to use this data from your machine. In this case, you have to somehow upload them to the Google Collaboratory environment, or in the case you are using a local installation of Python, you can just navigate Python where it can find the file and say Python what it has to do with these files. But it seems that nowadays you do not have to have everything on your own machine. It's sometimes even unpractical. It's useful to know how to get to the data directly from some online resources. And I normally use mainly with texts in Greek. So I do not work with data in Latin so much. But once I was thinking about what to choose for this exercise, I moved to this corpus, Corpus Corporum website. you find the link just here in the text cell below the importing packages. And it's actually a quite extensive corpus of ancient and medieval Latin text. It should now contain 160 million words, and it contains, it seems, the whole Patrologia Latina and some other resources. And from our exercise, I opened here the list of works of Augustine of Hippo. And basically, in principle, you can choose any of these works here and to, in a straightforward way, to import it to your Google Collaboratory environment. But what I want to, but some of these works are quite extensive, so it might take a lot of time to do some things with them. So I would prefer to use only shorter texts. And here was an opportunity actually to inspect the documents itself. Okay, let's do this. It's extremely slow. Yeah. The moment for the thing I wait for is this, to see this main screen here, because you see that for each document which is on this website, you can find this download, the place for download, and each document which is here, you can download either in the text file format or in this XML file format. And we are now interested in this XML file format, and we actually, in the exercise, there is a way, there is a code for importing this XML file directly from here to your Python environment without the necessity to download it locally to your machine and then from your machine to import it, to upload it to Google Collaboratory. You just need the link which is here. To obtain the link, you just have to click on the XML file, but by the right mouse button and copy link address. So I now use this de natura et gratia. I don't know what, I don't know this work, but it should work for us, or we can use the one which is already in the notebook. So feel free to find any work here on this website. It does not have to be necessary Augustine. It might be anything else. Adamus as Victoris. You just have to get to some particular word, and always you should find something like this, and you should be able to copy the link address. What to do with this? Once you have this link address, you can modify the code in this cell here. and replace either replace what is there or just to use what is there already. I had there the regula of Augustine originally. So what we did by doing this is we just define a new variable in Python, and this new variable contains a string, and this string is a URL address, and this URL address points out to a file in an XML format located somewhere on the web. But it's just at this moment on this line of the code, it's just a string. The more important thing is happening in the next step here, when you actually makes a command which in Python, which actually requests the content of the URL and actually scrape the content of the website to this variable called response. And this response variable within its text header contains now the document, the work of Augustine in this document itself. Once I run this command, I see here the final output. So in this way, by running this cell, we just find an XML on the website. We copy paste the URL here, assign it to a variable called URL because just for practical reasons, and then we make an HTTP request to get the content of this URL to Python. We assign this content to the response variable, but the response variable contains a lot of metadata as well. It does not contain only the text of the document itself. To get to the text of the document itself, or text of the content of the file itself, you have to put here the text method as well to use the text header. So now we have a textual data here in Python of a Latin text. And I suggest that we will run through this quite quickly right now to see actually all the procedure, how to get from here to some meaningful output in terms of computational text analysis. And then we return back here and we'll go look in more detail into actually what's happening in the command step by step. So all you need since now is just to run cell by cell from here to the end, and you should be able to see at the end, you should be able to see the interesting output, some output depending on what you have here. So here we got the text. In this command, you actually make a soup from the text. That means that you have to parse this HTML data here, this XML code here of the XML file. You have to somehow interpret them into a tree structure. Here we look how many words we have in the document itself. And so in the questionnaire, I ask you whether you know the TEI-XML files and their standard. So here you can see what I mean by them, by it. This is actually a standardized file structure which is used for producing digital editions of texts, mainly in humanities, but also in other domains. And it is actually a way how to publish in one file both the textual data itself and the combined with the metadata, because that's important, because once you have just a textual document just in a text file, you typically lost the metadata. But here the metadata are coded in a tree structure, and you can use this tags here, like HTML tags, to call particular values within the tree, which is very useful. So for instance, once you want to know the author of the work in this document, you just have to navigate properly through the tree of the file, and you can see who the author is. You want to get the title, you just have to put here into the tree the structure. But for now, I really want to go through this really fast, and to go again in a moment to return to this again and go into in more detail through that, because it's really crucial. So I will just run all of this. Here I do some cleaning of the data, textual data, and here I do some split it into text, into the list of words as we did before. And here is a code for lemmatization and POStagging. Here is explained what it is. And here I import some additional tools for text mining of classical languages for Latin, because to make a lemmatization in Latin is not so easy, so I have to use these additional libraries for that. It also contains a list of stop words. And what I do here, or what you can do here in this cell, is actually that you have now you have the document in this form as a list of words splitted one by one. And you are interested actually in basic forms of these words, because once you would count the number of occurrences of certain word here, it would be not so interesting, because you would not be able to find many of the forms of this, like here nature, and you are instead you are interested in natura here probably. So you have to run the lemmatization, but the lemmatization is a memory consuming process, because you have to the code has to go through some dictionary for each word, and for each word to look what might be its dictionary form, and return the possible dictionary form of the word. And here the function is written in a format that it already makes part of speech analysis. That means that it also tries to capture whether it is a noun, whether it is a verb, and in what case, and so on. So it takes time. We have a document consisting of 18,000 words, or I have a document consisting of 8,000 words, and I guess that it will take about 1 or 2 minutes to actually lemmatize and to make the morphological analysis for all of them one by one in Python, in Google Collaboratory environment. Once you would run it on your local machine, it's possible that it would be slightly faster, but my impression is that Google Collaboratory is fast enough for most of the things I do normally. You can also solve it by some parallel computing. So it took me 2 minutes and 28 seconds to lemmatize word by word a document consisting from 18,000 words. In the case you choose something like the Civitate Dei or something like that, you might get into trouble here. I would recommend to not use text which is longer than 30,000 words. Sorry, I should emphasize that earlier. At least for this exercise. So, and once we have the document lemmatized, you can see that the result here is slightly, or should be slightly better, but it's still not perfect because all these lemmatization tools have mistakes within, are not able to capture everything. But it seems that in most cases we have in the case of verbs, we have the first person singular. In case of nouns and adjectives, we have the first case. Yeah, my problem is that I am not a Latinist. I do not know Latin so much. I do not use it in my analysis, but I just try to do it with working with some data which would be relevant for most of you. So therefore we use Latin here. So another absolutely crucial thing you do most of the time is that you calculate the word frequency, the count of each word, and you can then sort the words in the document from the most frequent ones to the less frequent ones. The most frequent ones should be somehow more important for the document, or maybe just some very common words like the verb sum, which is actually not so much informative, or habeo. It's also to have, yeah, it's also very common word. In general, it's not so much informative, but it's here. So there is a very crucial Python package or Python library for doing this kind of stuff. Is called NLTK, Natural Language Toolkit. And I highly recommend for anyone who wants to learn on something more advanced on his own, on her own, to go here and to check actually the whole potential of this toolkit. It also has some support for lemmatization, but it's mainly focused on living languages. It does not support Latin naturally. But we have tools for Latin as well, as I have seen, as I have demonstrated here above. But one of the very basic functions in this NLTK library is this one, this fragdist, which actually goes through the document, through the list of words you have here, and for each term within it, it calculates how many times it occurs there. So it calculates that for the term sum, it has 35 occurrences, habeo has 25 occurrences, and so on and so on. And it produces the outputs in this structure. This is a list of tuples. In each tuple, there is on the first position, there is the word itself, and on the second position, it's the count, its frequency here. And the library, the NLTK library also contains this function called most common, and this most common function enable you to list a selected number of most frequent words within the document. Here I have the number 10, so that means that running this command, I get 10 most frequent words in the document coupled with the number of occurrences within the document, and I will print it out here. So here we see something slightly different than what we see that was here above. Before the data here were for the regular. Here we have it for this new document, for this. I forgot the name of the document. The natura and gratia. In my case, you might have something different here. So here I have the list of words, and you see that actually there is still a lot of things you do not like to see here, like this thing. So it would be probably appropriate to omit them from the analysis, to put these things on the stop words list. We will see below how to proceed with that. And once you have the data in this form, it's quite straightforward to obtain some very simple visualization. Here, still, it's from the previous running of the script. I have the data for regular, but I will run it right now. And now I have the actual data here. The Natura Gratia by Augustinus Hipponensis. So if you were successful in doing the lemmatization, if your document was not too large, in my case, for 8,000 words, it took 2 minutes. So perhaps if it has less than 100,000 words, you should be ready already now, and you should be able to produce the same plot for your document and not only for ordinary words, but for the word lemmata. So, how are you? How is it going? Is it running? Do you have your own plot of most frequent words?
Yes, we do. I do, at least.
Yes, most of you have, I hope, at least. Yeah, I don't see pictures of some of you, but yeah. Good. So my idea is here that you should really be able to run the script from the beginning to the end, and to really actually taste what's the possibility, even once we do here such very simple things. You might say, okay, that's very simple, it's almost trivial, but very often you can realize that actually the biggest task, the hardest thing is actually to clean the data into a form to be able to run something like here, something what produce some meaningful results. And you see that I used here for the lemmatization, I used the best tool I found right now, and still it produces a lot of trash, and you have to check it manually and realize, okay, perhaps this I should take this word out to list it into among the stop words, and so on and so on. And it's actually extremely time consuming. So in my impression, it is once you do a quantitative text analysis of this type and work with a whole corpus or something like that, you spend first 40% by doing by retrieving the data and their cleaning. Then perhaps 20% doing something interesting, some interesting analysis. Okay, perhaps I should use look at this word and this word and so on. And then again, you spend another perhaps 40% by producing something what you could share with someone else, to something what is clear enough and clean enough to be publishable, for instance. Like here, we were able to do some preliminary cleaning of the text, and we did some very simple analysis, just quantifying the most frequent words. But now you see that the results are still not sufficient, so you will have to go back and to clean the data again, to make some modifications in the code, and then you will be not sufficient. You will not be satisfied by the plot, so you modify the plot, and actually to get the plot into form which will be somehow useful, somehow ready for a publication, it again takes a lot of time. The first crucial thing here is, in my opinion, is the step how we get from knowing where the data are somewhere on the web to get them here into a textual into a form of textual data. That is the part at the beginning, actually, where I put the URL file somewhere on the web, a URL variable, and loaded it into Python environment, and then using the beautiful soup to do something like that. I think that this is something really crucial, and something what we should look at in more detail now, because I think that navigating XML files is a competence. You will, once you would like to work on this, to do some quantitative text analysis, computational text analysis, it might easily happen that you will need something like that on a daily basis. And unfortunately, there is no general solutions for all cases, because it seems that all XML files, even if they follow the same standards, are slightly different, and you have to inspect the file itself in detail first before you just run the script. You cannot just parse XML files completely blindly. So we will, I suggest now to make a 5-minute break. So we will meet again in 11:50, and then we will open another notebook and go through this process in more detail, step by step.